All right, so I think we're about ready to get started here. I'd like to introduce myself. My name is Jim Falbo with the AGC of Wisconsin, and I'd like to welcome everybody to our third installment of our safety series. Today we're going to talk about ladders and stairs, and we're also going to discuss just a little bit about electrical safety. How I'm going to have this set up is I have several pictures that I have taken, and Brent Miller and I have taken at several job sites, and it seems that it's easier to just to explain some general things that you see on job sites that could possibly be wrong with using stairs or with using ladders and stairs and several electrical issues. We picked ladders just because there is a national emphasis program by OSHA for ladders. It falls under the fall protection standard, under the fall protection national emphasis program. So what that means is that OSHA is able to come on your job. That gives them another reason to come on your job sites if they see just you using a ladder. Since it falls under the fall protection national emphasis program, they're able to inspect people using the ladder. So we want to cover that. We include electrical just because the electrical standard, the electrical hazards are part of the Focus 4 that OSHA has had for several years. And it seems that there's several electrical hazard injuries on job sites every year. And when I do go out onto job sites, even as early as last week on a job site, and still a lot of electrical hazards still persist. We all want to be able to trust that electrician, to be able to make sure they understand what they're doing, and being able to protect everybody when it comes to electrical safety. But sometimes they make mistakes too, and so we want to be able to try to catch some of that stuff. So we'll try to see what we can do to try to look to see what some of those hazards may be. So we'll start with ladder safety. Obviously, you see here, obviously not the proper way to use a ladder, but obviously you got to have some friends, right? So we'll start with step ladders. Again, step ladders, and I'm very cognizant of using this term, and the term that I use is common sense. I know we use ladders a lot. And for people that use them a lot of the stuff that we discuss is common sense if you're used to using a ladder, such as, facing the ladder when you're climbing up and down it, not having anything in your hands while you're climbing up and down the ladder, not carrying anything. So tools should be in a tool belt. Maintaining 3 points of contact, one hand at 2 feet, 2 hands and a foot all the time while you're going up and down the ladder. Make sure the ladder is level. So a lot of, the information here it's general knowledge that we probably have all been trained before on ladders. But we consistently see the misuse of ladders, especially using those top 2 steps as people getting on them. Some ladders, it's marked that you have to have, that there says it's not a step. The instructions on the ladder itself, it says that we're not supposed to step on those, those top 2 steps are not a step. Why is that continuing to be done using the top step? We're probably, different situations, maybe missizing of the ladder it could be a possibility. I know we have to get into some tight spots as well with ladders. You can see down on the bottom of the slide there, it says the wrong way to use a ladder. Again, leaning it up against using a step ladder as a straight ladder. And we'll see that probably here in a couple of these slides. Again, using the top 2 steps as a step should not be done just because there's a potential for you to fall. Again, why the ladder is put under fall protection national emphasis program are because of falls from ladders. Unfortunately, we have had fatalities where employees fall from a ladder as short as 3 feet off the ground, and unfortunately, they pass away. So falling from ladders is something that we have to be very, very careful of. And you can see the middle picture there on the bottom of the slide. We have a gentleman carrying something down the ladder and not facing the ladder. It's, you know, I don't, especially on a step ladder, that's kind of difficult. But hey, we're getting those tight situations. I have seen it before where people turn around on the ladder and they're not facing the ladder. Again, potential for falling off the ladder. So we have to also inspect that ladder to make sure that the ladder is safe to use. Make sure that there's no bent or cracked or rungs or braces or anything like that that's on the ladder. Making sure the ladder is fully open as well, so that it can fully support the weight that it is rated for. So again, some things that you should be looking out for just when you're setting up and looking at your ladder and inspecting the ladder before you use it, is to make sure that it is able to work properly for the task that you're going to be doing. So again, classic example of a misuse of a ladder. And he also is wearing his safety t-shirt. Love it. The couple things here. Obviously, we know the top step of the step ladder, but he also has this ladder in a doorway. When we place the ladder in the doorway, we should either block access so that someone can't walk through the doorway. If someone's carrying something, they could hit this ladder and then the employee would fall off the ladder. They wouldn't even be able to see if there's anybody on the ladder, because all they see is just, all you can see is maybe the top, foot and a half of the person if they're walking through the ladder. How many times are we walking around on a job site with our head up, or are we walking down with looking at the ground and we run right into this ladder and the guy falls off the ladder? So some things we got to be concerned about is when we're using these ladders and setting them in front of doors. Again, same company, and we blocked the name out just to protect the innocent here. But you know, we have an employee sitting on the ladder just waiting to do a task. Again, not the proper use of the ladder here. Actually, this picture here is always a good one. Brent Miller actually took this picture. He was walking around job site with a superintendent, and a couple things going on here is how there's an employee you can see at the top of the photo there, in a mezzanine or some kind of area, mechanical area, what have you, and he used this ladder to access that. So another problem that we've had is that you're accessing a higher level with a step ladder. Manufacturer's instructions clearly state that the only way that we can get on and off a step ladder is at the bottom. We shouldn't be getting on and off at the top. And another thing that happened here too is that he sets this up right in the middle of a doorway. Employee doesn't, if they're wheelbarrowing, looks like they're using wheelbarrows or something, they're going up this ramp that's underneath the ladder, and they say, "Well, who put this ladder here?" They move the ladder, and all of a sudden the employee is stuck. He can't get there. He can't get down because someone has taken his access away. Oh, by the way, the thumb in the photo, that was done on purpose because there's a light there, and you couldn't really get a good picture with the light shining in there. So that's Brent's thumb. Again, just another classic misuse of using the top two steps of the ladder. Again, it's an electrician, mechanical, fire protection person, whoever, trying to get up into above the ceiling grid and do the work that needs to be done. Again, just classic misuse. Here we have an employee using the step ladder as a straight ladder. Again, manufacturer says that we're not allowed to do this, and there's a potential, maybe not in this situation, but in other situations when we're using a step ladder as a straight ladder, where that bottom could kick out and then the employee falls and potentially injures himself. This is a classic picture. Several of you may have seen this. Brent and I we pulled this one off of either some website somewhere, and we were told that these are firefighters painting, and they're just trying to. They're trying to be inventive and try to get to a spot where they can't reach, but misuse the ladder. It's not properly supported. That's not even close. Here we have a step ladder being used as access for scaffold. Again, kind of what we talked about just a little bit before. Can't be accessing an upper level with a step ladder just because it's not rated that way. Plus, you know, then someone will say, well, what if I make it go 3 feet past? You know, still, we're not supposed to use a straight ladder to access a higher level. Only accessing the getting on and getting off the ladder from the bottom. And then, of course, you have someone using the ladder properly. Level surface, the clean area where he's working. Obviously, I understand construction can't be clean all the time, but there's no debris or anything where he's getting on and off. He could trip or fall. So, just to, you know, we do give us a lot of bad pictures, but of course we got to include a good one once in a while. So that brings us to extension ladders. With extension ladders, again, we have to maintain 3 points of contact when you get on these extension ladders, and not carrying any tools in your hands. Anyways, make sure the tools are in a tool belt. Make sure they don't get caught or anything on the ladder when you're climbing up and down. Again, not using the maintaining 3 points of contact when you're climbing up and down the ladder. Again, one hand, 2 feet, 2 feet in one hand. Shouldn't be carrying anything going up and down ladders. Again, if you're going to be placing the ladder in front of a door, this example here, either lock that door or have barricade the door so that no one can open the door while you're on the ladder. Also, with straight ladders, ladders have to be secured from movement. So when we're on these ladders, making sure that when we're trying to access a higher level, that they're secured from movement, so that when we get on and off, that they don't get displaced, and then there's a potential for people to fall. We have, I know several of our contractors have ladders, extension ladders ranging, anywhere from 10 feet to 50 feet. So again, if you're on a 50-foot extension ladder, which I'm sure some of us have been, that can be a fairly lengthy fall if we fall off that ladder. So again, making sure that it's properly secured from movement. Also, we have to, when we set up this ladder, it has to be set up at the manufacturer's requirement is that it's set up at a 75-degree angle. And that's where we get that 4-to-1 rule. So every four feet of height that the ladder goes up, it has to be set back at least a foot. So if it's up 8 feet, it's got to be set back 2 feet. So 12 feet, it has to be set back 3 feet. Just to make sure that we maintain that proper angle. If it's too close, the angle is too steep, and then the rungs won't line up properly, and you won't be stepping properly. If it's too shallow, there's a possibility that the ladder bottom could kick out if it's not secured properly, and you may go over the capacity of the ladder just because it's not meant to be used at that angle. So again, some other things that go wrong using the extension ladder: overreaching, reaching off to the side. So rule of thumb is usually you don't let your belt buckle go past the sides of the ladder when you're reaching for something. You don't overreach backwards, as you can see in the picture down at the bottom, second from the left. Carrying anything going up and down the ladder, we shouldn't be doing that. Also, with ladders, be them step ladders or extension ladders, if they're metal, we have to be very cautious about using them around electrical lines and electrical wires. Obviously, our aluminum ladders are conductive, and we don't want the electricity. We don't want to be shocked, because we will be past the ground if we're on the ladder when we're climbing on them. Also, making sure that we inspect the ladders to make sure that that the cleats are properly engaged if you're using an extension ladder. Again, a proper height we have to have for using this ladder to access a higher level, making sure that it goes past 3 feet past the landing area, that it's properly secured. That 3 foot extension going past, that's our fall protection for getting on and getting off the ladder. So it's nice to make you have that security when you're getting on and getting off the ladder. And so when we first use a ladder, obviously we see this ladder like this, we wouldn't be used. We just take this picture just to show an over exaggeration of a damaged ladder. When we're inspecting it, we're inspecting the ladder for damage. You can see we on the bottom of the page area have rungs that are bent. Obviously we have side rails that are very damaged. Obviously this was not in use. We saw this at a yard somewhere. Brent and I just decided, hey, this would be good to include in our presentation. Again, using an extension ladder to access a higher level. Everything looks good. The angle looks good here, but it's not secured at the top. So we have to make sure that's secured at the top so that make sure that doesn't move when you're getting on and getting off the ladder. Another good example of using a ladder. One of the things people sometimes forget about when they're using an extension ladder or using a ladder to access a higher level is that one thing OSHA does require is an offset. Is so that if you're, especially in here, would say that we didn't have this area where this ladder is sitting. I'm not sure why the precast is sticking out like this, but it's designed that way, I'm assuming. Maybe there's stairs or something are going there. I don't know. But the point I'm trying to make is that if this wasn't there and we would just put our ladder there, there's an opening in the handrail, and there's a potential for people to fall backwards if they're not paying attention to where they are. And so what the OSHA rule says is that if you do have access in the higher level, they want you to have at least a 190-degree turn to get onto the ladder. So that's what you have here, is that if the person for some reason is carrying something and he's going backwards and he doesn't see that there's an opening in the handrail, he would hit the back handrail. That's would be on the left side if you're on the bottom of the ladder, on the left side of the ladder, just so that he wouldn't fall off the edge of that upper level. So he has to make a 90-degree turn to get onto the ladder. Again, making sure the ladder should be secured as well. It's hard to tell here, but it doesn't look like it's very secure. Working in stairs. This is always a challenge for everybody when you're working with ladders or working in stairwells, trying to navigate, trying to get into a work position. And we see ingenious ideas like this, where we're using 8x8s and some old scaffold plank to make a platform. Great idea. What I'd like to see here, though, is making sure that all these pieces are secured together. The problem is, I'm not saying it's ideal. I'm not saying there aren't rule violations here, because the getting on and getting off, the problem is at the bottom is it's hard to get on and get off there, so there's a potential for you to fall. But I would like to see, if this was a situation, if it's something that I would come up on, I would want to see this secured together, just because those pieces can displace. And once those things displace, the ladder would fall and the employee would fall as well. So I not an ideal situation working in a stairwell. I'm not advocating that we should be doing this, just because you do have to have proper access to get on and get off the ladder without tripping or falling when you're getting on and off the ladder. A good example is this. This is a picture I took at a project where you come off the ladder and hopefully you don't fall on rebar or trip on rebar when you're getting off the ladder. So, we just asked the contractor, is there any way that we could move this ladder just into a different spot, just so that, you don't get a piece of, you don't trip on this rebar, especially if it's not bent over. It can be sticking straight up, and then, boy, you'd really get a surprise there. So it's something you got to be very, very aware of, is what's happening at the bottom of the ladder, what's happening at the top of the ladder, to making sure that you do have a proper access to get on and get off the ladder without falling. And again, we got to show some of these crazy pictures. Not that anybody would ever do anything like this. Sticking a ladder onto a Bobcat looks like trying to access. Looks like this is an HVAC contractor. Again, not the proper use of a ladder here. Also, trying to gain access. Again, this is kind of in the step ladder area, kind of in the wrong section, but still, he's still trying to gain height. He doesn't have the right size step ladder for some reason, or they just didn't want to move the table. That's probably more like it. And so again, you can see that there's a potential that ladder you can see is very close to coming off the edge of that table, and he would fall. Boy, he'd fall a good 8 feet onto a lot of stuff down there. You can see there's a welder and a bunch of other stuff that they have down on the floor. And this is a classic. This is a classic trying to hang up your ceiling fan, and you're using your ladder that you bought from Home Depot, and you bought a couple tie straps to go with it, and you're just hoping that your banister holds. Obviously, misuse ladder, there's not properly supported. So again, something that we want to make sure that we're using ladders properly when we're getting on and getting off them, just so that we don't fall. That's the biggest hazard we have with ladders. And then when we move on to stairs, again, stairs, I know we all use them. We prefer stairs, at least as a safety person. I prefer using stairs as the ladders, because with stairs, you can carry material up and down on stairs. But when we get into construction of stairs, there's still some things that we do have to consider when we're using safe access for stairs. Number one is handrails, guardrails, making sure that the pans are filled. Here in this situation here is that we have the stairs are put in, but the pans are not filled. Again, we've probably all stepped on and walked on stairs without the pans in them. We're not supposed to, and you understand why, is because that lip that sticks up on the stairs, you will trip right down the stairs, especially if you're trying to carry something. So those pans should be temporarily filled with material that prevents you from tripping, falling down the stairs. Obviously, another thing that we're missing here are handrails. So we have to have a handrail. Rule is for handrails is when is a handrail needed is if you have 4 risers or there's 30 more inches up a break in elevation, we're required to have a handrail. At minimum on one side. If there's a potential for falling, we have to have it on both sides. Also with stairs, and not making sure that we don't have material on the stairs themselves. We're walking up and down the stairs. Again, don't want to trip or fall going down the stairs. Unfortunately, I had a family member who was walking up the stairs and tripped going up the stairs and broke her arm. Yeah, broke your arm walking up the stairs. She had like 4 pins that had to be placed in her arm. Not very comfortable. Also, we always see a lot of electrical cords running around on the job site as well. Again, causes a trip hazard on the job site. So these things should be tried to keep them off of the stairs so that they don't cause a trip hazard going up and down the stairs. Classic example of using stairs to get into a job trailer. Seen this many times. Again, when we use this, that we have to have a handrail. But I said 4 or more risers, more than 30 inches. This is obviously going to be more than 30 inches. So you have to have a handrail on both sides here. OSHA rule says a minimum on one side. Is if you think about it, you walk out your job trailer, you have your office trailer or something. Stairs are going along the side of the trailer. You're protected on one side by the trailer from falling off the stairs. You need a guardrail on the opposite side. Here we would need it on both sides as well. Again, walking up and down the stairs. And this was at a job site where the stairs were poured, but I don't have a handrail. Have to have a handrail going up and down stairs, just because if you're carrying something, you have to be able to support yourself. So need to have those handrails installed. And then the last thing that we have with stairs, actually a couple things here. Talking about the handrail itself is that if we're going to be having handrails, making sure that when we have handrails that the handrail is smooth, that if someone's rubbing their hand along the handrail, that it won't give them splinters, or if there's a screw or a nail sticking out that they don't cut their hand. That can be problematic, is that if you're walking down the stairs and all of a sudden there's a screw sticking out, you cut your hand and all of a sudden there's a potential for you to fall down the stairs just because you can't grab onto the handrail. The other thing that's required is that if we have a door swinging out onto the stairs, there's a requirement that we have to have a landing. In the landing, the requirement here is that the landing must be 30 inches wider than the swing of the door. So if you think about it, I take that back. It's 20 inches wider than the swing of the door. If a person walks up to this door and they're going to go give it a pull to open the door and someone's behind it coming out, well, that person's standing on the stairs and they give it a push from behind and they're giving it a pull, that person that's sitting on the stairs can fall down the stairs. So again, making sure that if we're going to be putting stairs, and that goes back to the job trailer as well. If I can get there. The same thing here is that if we have a door that's going to swing out on a job trailer, again, there's a potential there that we have to have a landing that's 20 inches wider than the swing of the door. And the reason why we want the landing that's 20 inches wider than the swing of the door is that the person that can stand on the landing, and then if the door does open up, they are on the landing, they're not on the stairs themselves, and the door won't hit them while they're when the door is swinging open. Okay, so landing 20 inches wider than the swing of the door. All right, so that takes care of step ladders and straight ladders, and so now we're going to move on to electrical. So this is one of the areas that I concentrate on when I go out to job sites, just because I have found several problems with electricity, and it's one of those things that people just assume that they are being properly protected. And obviously, we see in this picture here that we have, having some fun, and hopefully this is hooked up to a GFCI. If it is, I'm assuming it's not working. If it is, and someone turns on the power, someone's going to be in for a rude awakening. But I always like to start when I go up to job sites. The one question I ask is I would like to see all of the, where is all the power coming from? How is it getting onto the job site? Where is it being distributed from on the job sites? I want to see all the temporary panels, and I want to inspect all the panels. I put this one in here. I have to describe the situation here. It's a little tough to see, but if you look on the bottom of this temporary panel, there's snow on the ground. And if you look at the panel itself, at the temporary panel itself, this is an indoor panel. Just because of I can tell just because of the door, the type of door that's on there, that's an indoor panel. It's not watertight, and there's no covers on these outlets at all to protect water from getting into these outlets. So what does the electrician do? He puts on this tarp. You can see the tarp's folded over backwards, so that if you're not using it, you're supposed to flop the tarp over the top to protect the electrical panel from getting wet. That is not the proper practice that we want to see. As you can see, it's not very effective here in this situation. I did not touch the tarp. This is the way I took the picture, is that all the electrical components are exposed to the elements. And I have to be very careful, is that if this panel was inside, I wouldn't have a problem. But this panel is still outside. There is no roof on this building. Obviously, there's snow on the ground, and the elements are able to get to this panel. So that's a problem that we have with the panel. The other problems that we can potentially have with panels are open holes. Again, this is an electrified panel where we have main power coming into it. The rule that OSHA has is that if they can stick a pencil into the hole, it's an open hole. It needs to be covered. So all these blanks that they have here need to be filled in. Same box. This is, this is on the bottom of the box. This is on the top of the box. So you can see big open hole there right at the top of the box right here. And problem that we have with this access is that this is giving us live access to the bus bar on the panel. So then I always ask people, I said, if we're going to be exposed, what's going to turn electricity off? we like to, we protect ourselves. We're protected by two programs that we have that OSHA affords us to use, and that's the Assured Equipment Grounding Conductor Program and GFCIs, Ground Fault Circuit Interrupters. Right? In this situation here, we are behind the circuit breaker. So there's a potential for you to touch live bus. And so now we're relying on the circuit breaker that powers this box. That's what'll trip. And so usually we have 15 amp circuit breakers inside this box. Probably the supply coming to this box is either 100 or 200 amps. And we're going to have access to 200 amps, 100, 200 amps. We're just asking for a potential problem. Again, same problem here is that this was up in a penthouse in a hotel that I was inspecting, and thanks electrician for telling me this is hot, but they removed the dead front, and I now have direct access to those bus bars. These are running all the motor controls for the ventilation units and everything else that is still live. So when you're working in remodel projects or anything like that, electrical is usually one of the bigger problems that I find, is because they're using house power, they're using a combination of house power and temporary power, and they have to get in and modify some of these panels while they're still hot. If this is happening, the electrician needs to be around this panel to make sure that he can restrict access to this. Obviously, I have access to it. I'm not supposed to have access to this. And so the electrician was not doing his job properly. He should have actually installed the dead front back on again. Also, again, saw this last week where we have circuit breakers missing. Again, access to the bus. That's what it is. I had, instead of, they're using tape here to fill in holes so that I can't access the bus, but still I shouldn't be able to have access at all. There should be dead fronts on there so that you cannot access that panel, that area in the back behind the dead front. Also, again, saw this last week as well, is improper use of lockout tagout. Again, when you are, situation we had is that we had a school remodel going on, and they were using the house power to power some temporary panels out of a house panel, and some circuits were turned on, some circuits were turned off. I questioned walking around going, okay, what if I start flipping these switches on? What's going to happen? Superintendent goes, I don't know. We need to lock those circuits out. If they're going to be live, they need to be locked out. If they're off for a reason, especially if they're redoing school rooms or anything, any room where the panel is, where you have power turned off, they need to be locked out so that people can't turn them on accidentally, or just a testing to see, well, what does this do if I flip this switch? I know, your people are probably saying, they said, well, you use your common sense. You just don't touch that stuff. Well, that doesn't happen. It just does not happen. It just takes one person to flip the switch the wrong one, and all of a sudden it electrifies something that someone's working on. We don't want that to happen. Again, another temporary panel that we have here. Again, the reason why I took this picture is because the main power that's coming in, you can see it's coiled in front there. I see a lot of this as well, where the power going into the panel, employees have access to this. And again, in order to get to this panel, to plug something in, you can see there's some dead fronts that are off on some outlets as well. In order to get to this panel, you have to walk on this cord that's powering this panel. The problem is that what's protecting me if I step on this and I break the outer covering, or there's a breach in the outer covering of this, what's going to turn the power off? Again, this is feeding power to this panel. It's probably a 100 amp, 200 amp breaker. That's what it's going to take. Then the question that we have is, how many amps does it take to potentially kill somebody? It can be as little as 5 milliamps, 6 milliamps could put, actually probably more than that, probably closer to 20 milliamps potentially stop you from breathing. Get up to 75 milliamps, that could potentially stop your heart. So, and then we're talking milliamps, we're talking amperage here. I mean, so it's a multiplier of amps that we have in this area, in this situation. So again, making sure that this main power, what we want to see is that we want to see this main power either up off the floor, tucked in behind, or it should be covered. Some electrical contractors, if they have to run it along the floor, this main power to feed this panel, they will either raise it up off the floor so that it's not underfoot, or they'll cover it with drain tile, that split drain tile or something like that, just so that it's protected, so that people can't have access to it. Again, took this picture. This was at a building going up. You can see this powering a fairly large transformer in the back, and the power is coming up through a hole. Now, what OSHA rule has when we're coming up, power coming up through a floor, is that we have to protect this area where the power is coming up through the floor. Just because if we're sliding something across the floor and we hit this power cord, we can sever it and break it off like a guillotine. And so this has to be protected. When we're going through doorways, when we're going through holes in the floor, we're going through holes in the wall, that area, all those areas have to be properly protected. And again, I like to come to the breaker box where the distribution center is, because here I can look at cords. I can see what's going on here. Again, we have a couple things going on here. We have the Assured Equipment Grounding Conductor Program. Again, if people aren't familiar with that, it's something where we test the continuity of the ground in the cord quarterly. Currently, right now, it is July 23rd. We are in the red quarter. So if you're using the Assured Equipment Grounding Conductor Program, we test the continuity of the ground in the cord to make sure it's continuous throughout the cord, and then we would wrap a red piece of tape around the male end of the cord. And so then we can then see that we have a green one here, we have an orange one, we have a really bad repair on a cord there. So, if we're using the Assured Equipment Grounding Conductor Program, I'm not sure which one we're supposed to have depending on the type of year we have. I also look for a cord damage as well. If you look on the bottom cord, way at the bottom, there's a strain relief issue there. And I don't know if I have a picture of that. I may have a picture. I thought I had a picture of that. Maybe not. But still we have strain. So there's a picture of strain relief as well, where we have the wires or the insulation is actually pulled away from the plug. That is what we call strain relief. The rule says that we're not supposed to put pressure on the screws that are inside the fitting, and so this allows us to do that. So we're not allowed to put pressure on terminal screws. I'm sorry. So that's what you can kind of see that in this picture down here, down on the bottom, that they have. This is a common problem that I see is strain relief. I want to talk just a little bit more about. I talked a little bit about the Assured Equipment Grounding Conductor Program, but I also want to just make sure that people are aware of the other option you have is the ground fault circuit interrupter. Because you can see on this panel, we do have ground fault circuit interrupters. So as long as we have ground fault circuit interrupters, we're okay. I would ignore the tape job that's going on here, just because they are using the ground fault circuit interrupters. Some companies use both, which is fine. If you're using house power, like in a school and you're using house power, making sure that you have to use the Assured Equipment Grounding Conductor Program if you're not using a ground fault circuit interrupter. That's when the taping and continuity of ground comes into play. So what I like to explain is just what a ground fault circuit interrupter is. A ground fault circuit interrupter measures the electricity going out on the hot, coming back on the neutral. If there is a difference between the electricity going out on the hot and the electricity coming back on the neutral, the ground fault circuit interrupter will turn the power off. So what the ground fault circuit interrupter is sensing that the power is going out, but it's not returning. Does that mean it's leaking somewhere? It's either going to ground or it's going through you. And we don't want that to happen. So the ground fault circuit interrupter senses that and turns it off. It depends on the interrupter you're using. Some of them are very sensitive, and it'd be 0.5 milliamp difference between the amperage going out on the hot, coming back on the neutral, where it will turn the power off. It will turn the power off in 1/60th of a second. As soon as because it's constantly measuring the power the power going out on the hot, coming back on the neutral. So that begs to the question is, what would you rather use? A ground fault circuit interrupter, or would you rather use the Assured Equipment Grounding Conductor program? What protects you? What gives you a greater level of protection? Where the ground fault circuit interrupter will actually turn the power off if there's a difference between the power going out on the hot and coming back on the neutral. Where the ground fault circuit where the Assured Equipment Grounding Conductor program, all that's doing is making sure that you have a continuous ground through the power cord. So what they're trying to do there is establish that you at least you have a path to ground in the cord. But that doesn't mean we've tested the outlet. We haven't tested the tool. It's not required that we test any of that. It's just required that we test the cord. It's cord sets only. So what protects us better is the ground fault circuit interrupter. Why do people get angry with the ground fault circuit interrupter? Is because sometimes it keeps tripping. Well, that means it's telling you something. That means that the power is leaking to ground somewhere, and you have to find out what it is. So you have your cord running through a puddle, keeps tripping. Wonder why? Because the ground because somehow water got in that cord and is leaking off of the hot, and it's not coming back on the neutral. So that's how the ground fault circuit interrupter would work. Again, we talked about strain relief. Again, just another example of strain relief here. You can see that this is on a sander for a plaster. It's using a stick sander. Again, turtles. You got to watch these too. People are pulling the turtle around by the cord that it's by the power cord that it's connected to it. This is the main power cord going to it, and it has a strain relief issue. Again, can't have that. This one is always fun to look at, because I always try to figure out where is the power coming from. We have to talk about overloading a circuit here, is that we have one circuit powering 6 cords, okay? Again, this is a 15 amp circuit. Depending on what we're powering, we may be overloading something. Actually, we're powering 7 things. I want to say the power is coming in on the green up on the top there, and then it's powering, 1, 2, 3, 4, 5, 6, 7 plugs. So yeah. So overloading the circuit. Remember, it's a 15 amp circuit usually. You put on 1 dehumidifier onto those circuits. You got to look at the load of a dehumidifier. Probably, depending on the size, can be anywhere between 12 to 10 amps of draw. Boy, you start putting on fans and stuff like that to try to dry out a building, you can overload a circuit real quick. The other thing that we have to be careful of as well is when we have power running through the building and we have terminated ends. A couple slides that we have that are like this. Now, we want to see these terminated ends be at least 8 feet up off the ground so that there's no way that we can contact them. Thanks, electrician, for putting the danger tape on there. We know it's dangerous, but it needs to be protected. If we're not going to have it up more than 8 feet, we need to have a junction box put there. Either a junction box or some kind of other form of protection that if we would hit it, that we're not just protected by electrical tape. Something we can't have. Again, same thing here, same type of situation. This one's actually lower to the ground. This is probably only 2 feet up off the ground. You can see that the electrician's holding up something there. I'm not really sure what's going on here, but still we have exposed power. That's live power that is not properly protected. And again, it wouldn't be an electrical presentation if we do not show metal track and cords going over the metal tracks. Again, potential damage here. We all probably have seen it, and we all know it, how sharp those are, and there's potential to damage the cord. And if we don't have a ground fault circuit interrupter, there's a potential to electrify the wall, which we don't want. So if we're going to do that, again, have some areas where they're going to pass through, fill those in so that there isn't damage at all. They won't damage the cord. We could do this as well. Take a track, put it upside down just so the cords can pass through without being damaged. And again, I'm not going to say that anybody would ever do this, but I have seen it done on job sites before, is that people run cords through the holes that are up on the left there, in the piece of steel. They run a cord through that. Well, it just cuts it all up. It was ridiculous. You can see the coating being stripped right off of it. And again, how are we storing our cords? Again, cords can, cause a trip hazard. We want to try to get, if we can, potentially get these up off the floor if we can, or at least get them to one side. The problem that we have on job sites as well is that if we're using a lot of lifts, maybe not in this situation here, but maybe you're using lifts, and I've seen this all the time, is that people are running the cords over with lifts. Can't do that. Cords can't be run over with lifts. There's potential to damage the cord that way. They all should be up off the ground or to the side so that we don't walk on them, so that we don't trip on them, and we don't run equipment over. You shouldn't be run over with equipment. So that's even like running across your job site where we have maybe a driveway where you have cords going across. I've seen that before too, where we have pieces of equipment, be the forklift or dump trucks and concrete trucks and pickup trucks, are running over a cord. Obviously it would damage that cord very easily. So we shouldn't be running cords over. And of course, we have to talk about lighting. If we're using temporary lights, again, one of the rules for temporary lights is that lighting must be on a dedicated circuit. So that if you're using temporary lights on your job site, again, making sure that it's on a dedicated circuit, just so that we don't want to make sure that we don't have our table saw connected to the same circuit that the lights are on, and we cut a piece of treated lumber and all of a sudden the lights go off because the saw overloads the breaker and then the breaker turns off. So dedicated circuit for all lighting. In this situation here, if we have a light string, the light must be protected from damage. So that means they have to have the cage around it. Also, we want to make sure that that cage is filled with a light, because we have that's exposed conductor there. If that light string is powered, there's power going to that light string, we have an exposed conductor. And who knows what would happen if someone would stick something, not that you would stick it on purpose. I'm not saying anybody would ever do that, but accidentally. I mean, it's you always hear those accidents, 1 in a million, never would happen ever again. We want to take away those situations. Again, we have another problem here. Light is missing, power is on. And now this is at, 6 feet off the ground, right at the level where you could potentially, something could accidentally go inside this socket. Again, strain relief issues here, bulb not protected. We shouldn't be hanging lights this way at all. This is in some job trailer at some job site somewhere here in Wisconsin. So again, make sure it's properly protected when we're using temporary power. Again, with these halogen lights too, the sodium lights, I should say. Again, we have to this light bulb you'd think is protected, but sometimes those OSHA inspectors get real picky, and it's true. The light bulb is not protected because the bottom is not protected. Something can jam something up into that light and hit that light bulb. So we have to have the bottom be protected as well. So similar to this, I know it's hard to see. This is an LED light that I saw on a job site. Really nice light, properly protected, that we have here all the way around. Here's another one where it's properly protected all the way around that light bulb, so that the light bulb is properly protected and won't be damaged. This is a picture I took. Again, this is one of those pictures that you kind of have to explain what's going on here. This was a remodel project at an elementary school. And actually, when this was going on, the elementary school was still in session. So their school was still in session. And I walk into the to the main electrical room where the contractor has removed the door to this electrical room. And the children will be able to walk past this door. So they did have access to this room, and it didn't have a door. And this is the main panel for the main power coming into the building. So this is a 200 amp breaker. Electrician must have, I don't know when this happened. This was not done by the contractor. This was done by somebody else prior to work being done. But I could take my fist and stick it into that hole. Not that anybody would, that I would do that, and I wasn't about to do it because obviously we have a lot of power back there. But my point is that we have students that are walking around that get curious, and they would stick their hand in there. That's the problem that we have here in this situation. And so again, making sure that if we have areas where kids that we need to restrict access, rule is if we have over 600 volts coming into in a room, we need to restrict access to that room, and it has to be labeled and locked so that no one can get in it. So again, making sure that we are restricting access to the proper areas. But even when we're working at elementary schools, even though some of the closets have breaker panels in them, and then we start taking off the dead fronts and we start leaving doors unlocked or taking doors off, and now kids have access to these panels without the dead fronts, boy, we're just asking for a potential problem. So again, making sure that we keep that stuff covered up. Again, elementary school, and we took out a light switch. That's still live in there. Some person can come by and stick their hand in there. Again, we have to understand what the hazard is. And I know people have so many things going on in their job sites, but it's these little things like this that potentially can be a problem. Here, I was on a demo of a school, and I was walking around with the superintendent, and I said, okay, we're demoing this area. Is all the power off? He goes, it should be off. So I stick in my tester, and lo and behold, that circuit's hot. And they're demoing around it. And obviously you can see they demoed around it and took stuff away, and it's hot. And so again, potential for contact there. And the last picture that we have here is of the classic light switch with the panel off. Again, if it's live, we do have access. I know it gets ticky-tacky when we start talking about light switches. And I know we get near the end, we're not putting those light switches on, but technically, if we see light switches and outlets that are hot and don't have the covers on, then there's a potential for someone to come in contact with that circuit, with the live circuit. So we have to make sure that all that stuff is covered. Also, some things that we didn't cover here were damaged cords. I didn't talk about any of that. If you have any questions about cords, cord repairs. Again, there's something that we have to be very careful with cord repairs, is that we do see a lot of people using electrical tape to repair cords. If the outer covering of a extension cord is breached, we can't use electrical tape to fix that. We have to make sure that the water resistance of our repair is as good, if not better, than the manufacturer's water resistance. And so if we just cover it with electrical tape, there is ways for water to get in there. And then all of a sudden you start plugging your cord into a GFCI, and it starts breakers. The GFCI starts going off, and you start getting angry at it and saying the GFCI is bad. Well, we have to be able to test those GFCIs as well. So again, making sure that we understand what some of those problems are on the job site with electrical hazards. With that, that's about all the information that I have for you today. If you have any questions, I have my contact information up there for you. Please feel free to email me, to call me. If you want to send me a picture of any type of situation you have, I'd be more than happy to try to help you out on what some of your potential safety problems are. So again, I appreciate everybody for showing up today. And again, if you're interested, next week our next installment of our little safety discussions on Thursday morning will be on trenching and excavating. So we'll talk just a little bit about subpart P and some of the general requirements for trenching and excavating next week. So other than that, if there are no questions, please give me a call. And if not, we'll see you guys next week. Are there any questions from everybody that's around? No, no questions, no worries. Other than that, we will hopefully see everybody next week. All right. I hope you guys all have, do you have a question?
Yeah, Jim, can you I thought you can't repair extension cords.
It's not, you can repair extension cords. The problem is that it's very time consuming and tedious to repair an extension cord. So like I said before, is that if you are going to repair the extension cord, you have to make sure that you are going to, make sure that the water resistance of the outer covering is equal to the manufacturer's water resistance. So that means if you're going to you have to use that shrink wrap stuff if you're going to repairing the damage on a cord. One thing that we have had issues with one OSHA inspector out of the Appleton office is that he kind of gets all uptight about replacing cord ends. And he says that people aren't allowed to replace cord ends. That's not necessarily true. So you are allowed to replace cord ends as long as you understand you have to have some proper training when you're replacing cord end. Does that make sense?
Yeah. Yep.
So
okay. Thank you.
Again, when you're repairing cord, if you are going to repair a cord, not necessarily putting on an end, but just repair a cord, you have to make sure that even the individual wires, the hot, the neutral, and the ground have the proper water resistance as well. So that you have to shrink wrap those, then you have to shrink wrap the whole thing together. So you can see you'd have to cut the end off in order to do that. So it seems like it would be fairly time consuming, but there is a way to repair a cord. It's not an easy way, but there is a way.
Okay.
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 Good question. Thanks for asking. Any other questions? None. All right. Well, I appreciate everybody for participating today. And again, like I said, you guys all know that I'm more than willing to answer any questions you have. So just give me a call. All right. We'll see everybody, guys, down the road, or hopefully we'll see you next week. Thanks for participating. We'll talk to you guys soon.